recording. And so welcome everyone. I'm Sonu Bhaskar here, Chair of the Youth Committee at the Rotary Club of Sydney, and I'll be chairing this meeting today. At the outset, I would like to acknowledge the traditional custodians of the land on which we are meeting today, and I'm the lands of the Gadigal people of the Eora Nation. I'd like to pay my respects to the elders, past, present, and emerging, and acknowledge all Aboriginal and Torres Strait Islanders here today, and also paying my respects to the elders, past, present, and emerging. Well, as you know, the Rotary Club of Sydney endorses the Uluru Statement from the Heart. Today, we are holding the third edition of our Rotary Youth Talks. All these talks are recorded and then put on our website for everyone to view. So a bit of background on Rotary Youth Talks. It's a program to attract youth, Rotary alumni and scholars, as well as guest speakers with relevant backgrounds to share their experiences and insights on youth participation, capacity building, and broader engagement. Question for us today is, how do we cultivate youth leadership for a kinder and better world? We'll reflect on this during the course of our meeting today. We'll hear and get inspired from our guest speaker, Gabrielle Phillips at the University of Wollongong, Australia. Today, she will share with us her journey into Huntington's disease research and some of the exciting work she's doing at Wollongong. Following the talk, we'll have a roundtable discussion. I also want to say that this is a safe space where all ideas from everywhere are welcome. So please feel free to participate and share your views through the question and answer chat function on the Zoom. Allow me to also extend a special welcome to our guests who are joining us here today. And on that note, I would just want to introduce Gabrielle. Well, Gabrielle is an exciting and a phenomenal young leader from Wollongong, from our rural New South Wales. And she's a Wollongong local and an associate research fellow at the Illawarra Health and Medical Research Institute at University of Wollongong. She is interested in the neurodegenerative genetic illness, Huntington's disease, and examining how this disease alters the lipid chemistry of various brain regions. She hopes this research will assist in unraveling a treatable pathology for which none currently exists. Well, Gabrielle did her bachelor's degree in medical and health sciences from University of Wollongong in 2016 and started at IHMRI at the following year as an honors student. She got a PhD scholarship and went on to pursue a PhD in 2018, which she has recently submitted. And as I heard before from Gabrielle, she is just about to finish a revision of the thesis. So we wish her all the best in finishing her thesis and handing over the big document. Well, in 2019, her research in Huntington's disease has been supported by philanthropic funding, which enabled her current position at the university in April of this year. And she sits in a number of community advisory committees on Huntington's disease. So welcome, Gabrielle. Over to you, Gabrielle.
Oh, hello. Thank you so much for having me, Sonu, and hi. Sorry, I don't know where to start.
Gabrielle, you can start in any way you want. You can give us a brief introduction about yourself and about the Huntington's disease and the research you're doing.
Okay. So I'm based at IHMRI. So it's a medical research institute that sits on the Wollongong campus. So it's actually a charity. So it's a not-for-profit that collaborates between New South Wales Health and the university. We have a lot of researchers here focusing on a lot of different illnesses. So Sonu was highlighting before, we've got motor neuron disease, vanishing white matter, diabetes, cardiovascular disease. And I focus on Huntington's disease. So that's a genetic neurodegenerative disorder which causes the progressive breakdown of the central nervous system. So with the disease, because it's genetic, it's caused by a mutation on the Huntington gene. So everybody has two Huntington genes. They've got one from mum and one from dad, but people with Huntington's disease have this thing called a CAG repeat mutation on their gene. So CAG is a little code that encodes for a protein called glutamine. So the Huntington gene makes the Huntington protein, and people with Huntington's disease have these little extra glutamines on the end of their protein. What that does is that causes that protein to get stuck in neurons in the brain, and then it causes them to progressively die. So the problem with this disease is that even though there's been so much research into it for years and years, no one has been able to find a pathology that's effectively treated. So we know lots of things about the disease, but there's nothing that we can actually interfere with to slow it down or to really alleviate any of the effects. We just can manage the symptoms. And so what my work is interested in is just trying to understand the disease better, because you can't treat something if you don't understand it. And we focus on lipids. So they're usually kind of, I guess, a smaller part of research because it's not really realized how important they are. When we think of lipids, we think of, fats in foods and that, but in the brain, they have this really critical function where they actually tell our cells when to die, when to change the type of cell they are. They actually change the function of our neuroreceptors and the function of our neurons. So they have this really, really important job, and sometimes they're a bit overlooked, but this kind of research is starting to really recognize just how important they are. So in Huntington's disease, I'm hoping by understanding how the lipids are changed, we can decide how we could possibly change them back, and what the brain is potentially lacking. So if it's lacking a certain type of lipid, maybe we could supply it back. Yeah.
Fantastic, Gabrielle. And can you tell us more about why did you choose to enter this in this discipline in particular, but more so Huntington? Is there a personal story that inspired you?
So I did medical science at University of Wollongong, and when I finished my degree, I actually went to go and work for the Red Cross. So I was working as a blood technician in their facility in Sydney. And during this time, a family member of mine got diagnosed with Huntington's disease. And unfortunately, for a lot of people that have it in their families, not everyone is aware of it. There's a lot of stigma with the disease. And so unfortunately, people tend to hide the fact that it's there. And it becomes quite secretive. So at the time, I was told it was a secret. So I decided that I wanted to try and make some sort of contribution. So I searched around and I found that someone at Wollongong University was looking for an honours student to look at Huntington's disease. And I thought, okay, here we go. This is how I do this. So it was a bit scary. I had an interview with the supervisor, and I was waiting to hear back, from the university whether or not I'd been accepted, but I kind of took a bit of a leap of faith, and I just I left my job in Sydney to get an apartment down in Wollongong and to start, and it turned out really well. So everything went through. That was a bit of a jump. And yeah, I started as an honours student, which was also a little bit challenging. Something I was telling Dr. Hennessy about with my research was on my very first day of my honours degree, I was very excited. I was looking forward to my project, and my supervisor said, "Oh, we need to talk." And they'd actually got offered a job at UNSW and they were leaving. So on my first day, I was told that I'm so sorry, but you're going to have to find another project and another supervisor, because I got this job, and I'm leaving in about 6 weeks. That was really hard, and I was pretty determined. I'm a little bit stubborn with what I wanted to do. So I said to her, "Is there nothing that can be done? I don't want another project. Can we just sort something out?" She said, "Oh, my boss could possibly help, but I don't think he wants a student, but we could, try and talk to him." And so I found myself in his office, saying hello, introducing myself for the first time. and then, you know, subsequently asking him if he wouldn't mind taking me as a student in an area that he didn't study. So that was kind of interesting. He doesn't do Huntington's disease research. He does a lot of lipid research though. So he works a lot on eyes, and he's done a little bit of work on Alzheimer's disease. But he said to me, you know, if you can carry your own till June, that's when my teaching load lightens and I can look after you. If you can try and manage until then, you know, you've got yourself a deal. And what's kind of special about that is it's 5 years later and I still work with him. So I did my PhD with him, and now I work as a postdoc in his lab. And I kind of look back and it's a really kind of fond memory. Neither one of us expected to be working together, but it's worked out really well. And I'm really, really grateful. Like, if he hadn't have said yes, I would have had to completely ditch all of my research and none of this would have happened. So that's kind of a special part of the story.
Gabrielle, that is fascinating, and I must acknowledge that, you know, the journey of us and somebody in medicine or in research, it has to be driven with a bit of stubborn. You got to be stubborn because most of the questions are unanswered. You know, and until that a passion to solve unsolved question is not there, we will not get somewhere. So, you know, it's important that you stayed at Wollongong. It's also important that you pursued that research with somebody else. And I'm very glad for your supervisor that he supported in your journey. Now, you know, it's a subject which is very close to my heart. As you know, the Huntington's disease is not a common, but it is quite a regular presentation in neurology clinics. And many of these patients start at age of 30, and in between 30 to 40, they get diagnosed and they present with clinical symptoms, psychiatric symptoms, behavioral symptoms, and many of them in the early phase of their disease do have movement symptoms as well. And much of it, as you know, there's a stigma around the Huntington's disease. Many patients don't want to come to the clinic, and we got to get the genetic testing done to get a confirmation on the diagnosis. So getting the patients to the clinic is a big problem. And then, and more so, you know, breaking that big news that you have a Huntington's disease is a bigger problem, because many of the patients and the family are not prepared for it. You know, unlike other conditions, when you have a diagnosis at 60 or 80 or 90, not taking that any age of diagnosis is you know, bad, but at getting a diagnosis of Huntington's disease, such a debilitating condition at 30 or 40 is quite a challenge to the family. So can you tell us more about, in your research, have you met some patients who had Huntington's disease, and what is your experiences in working with the patients? What do they tell you and inform your research? Gabrielle.
So all of my research focuses on postmortem tissue. So I actually work on brains, so donated brains from Huntington's patients and their families, which is pretty amazing. It's very, very rare to get your hands on. So we're extremely careful with it. But I have met quite a lot of Huntington's patients through Huntington's New South Wales. So I sit on the community advisory committee for the charity. But also through my research in some very unexpected ways. I mean, for confidentiality purposes, I can't say exactly where I met them, but it was a lot of situations where I casually mentioned what I did for a living, and that person turned around and said, I have that disease, or I think I have that disease. And it ended up, you know, in this really amazing, quite personal chat with them about how it had affected them. For the patients, it's exactly what you said. People don't talk about it. So, you know, if you've got a parent with the disease, you've got a 50% chance of getting it too. And there's a lot of stigma, you know, people don't want to know, because if they tell others, you know, how is that going to affect their ability to have relationships? How is that going to affect if they want to have children? And how is, you know, their friendships, their whole life, and, you know, even their jobs. I mean, we'd hope that people weren't, you know, prejudiced, but that's not always the case. So people are quite secretive. And as you were saying, most people don't get tested. They don't want to know, because since there's nothing you can do, you know, a lot of people just think, why would I get tested? So I think that Huntington's disease, out of all the neurological diseases, has some of the best participation rates of people who have the disease in clinical trials. I have noticed that. People that are symptomatic, they're very engaged. You know, they want to go to the clinical trials, they want to be involved in the research, they want to know. And all of the people with Huntington's that I've met, they're very knowledgeable. Like, you know, they're reading the scientific journals, they're keeping up to date, they know exactly what's going on, which is pretty amazing. But yeah, it's been really lovely to meet them, because, you know, with science, sometimes we're a little bit far removed from the people that we're trying to help. And so I think meeting all of those people constantly, you know, kind of really fulfills that deep personal connection that I have to being a scientist and trying to make a difference. So lovely part.
Fantastic, Gabriel. And on that note, I just want to acknowledge our past district governor, Di North, who is joining us here today. And she's also from Wollongong, Gabriel. So you've got another Wollongong, fellow Wollongongian joining us today. Welcome, Di. And Gabriel, on that note, you know, one of the challenges of people with neurodegenerative conditions are that, as you know, the diagnosis is such a taboo, and opening that. It's very important, despite we don't have much options in terms of treatment, it's important that the patients come out and get tested, get a clinical diagnosis, because we can help them. We can help them in providing particular pathways, physiotherapy, so and so on. So at least the symptoms, the physical symptoms or the motor symptoms can be managed. Now, in your work, Gabriel, you're looking at post-mortem samples of these patients. So can you tell us more about how do these patients get enlisted in the biobanks? What do they have to do? And for the community to know, what is the way to get into and donate their part of the body or the brain to advance future research? Gabriel, over to you.
So these people have, I think, usually made specific instructions in their wills in terms of donating their brains. But I think it is the families that do have the final kind of push towards the donations, because people with Huntington's disease, by that end stage, you know, they've got very, very severe dementia. So these brain banks are all over the country, but there's actually quite few of them left. What will surprise people is that the brain banks around the country have actually been shutting because they've had a bit of a lack of funding. And there's a few left, and the one that we get all of our tissue from is a Victorian brain bank. So they're down there at the Florida Insitute of Neuroscience, and they supply us with all of our patients. So I think I did, you know, a bit of just a little investigation, and we have, I think, approximately 39 Huntington's cases in the entire country at these brain banks. There's not very many of them. And of those, we have 13. So yeah, these people donate their brains to the brain banks, and what the brain banks do is then they dissect the tissue into all of the different brain regions, and then scientists have to put in applications about how much tissue they'd like and what they'd like to do with it. And the brain bank judges the merit of those applications. So they decide, okay, how good is your research idea? How well thought out is it? How much could it possibly help? And then it's just, yeah, it's competitive allocation of tissue. Which is really, really amazing, because they have very skilled neuroanatomists that know how to dissect every single little region. So yeah, the work they do is amazing.
So that's fascinating, and Gabriel, and somebody who's also done a lot of work in biobanking. And I must admit that the donations and also the sustainability of these biobanks is a big challenge right now, and many of the funding is quite limited. So it's an important area, and people must, you know, the community realizes that the amount of work that goes into looking at these tissues does inform future research, and that advances sciences and clinical practice. So whatever we have today, the knowledge that we have gained is because of the research that has been done on these patients. And thanks to those patients and community members who has been active supporters of this research. Now, Gabriel, one of the important questions that came through while discussing some time back with a community member and also a patient with dementia. Now, how is it important that researchers should talk to patients and community to understand and inform them about the importance of research in advancing science? And you, as a young and emerging researcher, what is your message to the to the community that how can they be an active participant in this particular work? Gabriel.
I think one of the things that I would like to say to the community is that the scientists absolutely love when the community come in. They get really excited. Well, we get really excited. We absolutely love the community involvement. We love meeting patients with diseases that we work on or people that are affected by that disease, you know, so family members. And, you know, community engagement is such an important part of research. And it really drives home to the scientists, you know, how important their work is, and that motivates us, makes us work that much harder for our goals. I think when it comes to people that are at risk for Huntington's and, you know, they're feeling like they don't want to, you know, they don't want to think about it, they don't want to go down that path. The thing I would say is that there are a lot of fantastic community support groups. So Huntington's New South Wales that I spent a lot of time working with, they have support groups in so many different cities and they're absolutely lovely. And so, you know, using them, you're able to connect with people that are going through the same journey, that understand exactly what you're dealing with. And the other thing is, you know, with our scientific studies, you don't have to know if you've got the disease to come in and participate. A lot of the studies of, like, you know, the scientists are very aware that most people don't want to know, and that's okay. You can still donate, you know, plasma, you know, blood, or, you know, all sorts of, sometimes skin. People use skin to make iPSC stem cells. So they're just like, you know, a little scraping or saliva. And we don't ever have to tell you if you have the disease. We can keep that completely to ourselves, or we can even just not find out ourselves, because looking at people who are at risk for the disease gives us a lot of information as well. You can have a look at how that person is progressing. So if you do want to be involved, there are definitely ways and people to support you and to definitely make sure that we keep your interests at, you know, at the front.
Absolutely, Gabriel. And just to reinforce that idea, patient autonomy and confidentiality is critical to biobanking, and all patient-related information is anonymized in all these samples. So, you know, we do respect patients' privacy, and it's important to highlight that in our engagement with the community. Now, Gabriel, that when you get these tissues from the biobanks, which is the particular part of the brain which you look at? Is it the Broca's area? Is it the motor cortex? Which part of the brain you are interested in?
So the big one in Huntington's is called the striatum. So it's this area of grey matter in the middle of the brain that's involved in voluntary movement and cognition. So it's kind of like the integration center for your brain. It's taking information from all different various parts and actually making sense of it. And that's a big one in Huntington's disease, because that's the area of the brain that degenerates the worst. And that's actually what you see on MRIs when you're looking at patients, is this really pronounced degeneration of the area. It makes these very big holes in the brain. But so we've been focusing on the striatum for about 5 years, but more recently we've started to branch out into some brain regions that aren't as well looked at, and some of that's the white matter of the brain. So you've got grey matter on the outside, grey matter on the inside, and the white matter is connecting those two parts. So it's like your little pathways, and it's the one that's moving the information around. Now, we know a lot about how the white matter, it shrinks in the brain, but no one really knows what's shrinking. So the actual part of the white matter, so, you know, is it the actual neuron itself? Is it the fatty coating on the neuron? Is it, you know, potentially some support cells that are dying in there? And so we're looking at 3 distinct parts of the white matter. So frontal cortex at the front here, the corpus callosum, which is right in the center of the brain and connects the 2 hemispheres. And then we're also looking at the internal capsule. So this is a little part of white matter that runs directly through the striatum. So by doing that, we're kind of hoping to get, you know, 1, 2, 3 kind of views of the white matter and have a look at how that's changed. So I'm excited. That's our new project this year.
Very exciting, and you're right, the striatum is quite an important, has been very well established in neurology in terms of there's the Huntington's disease. But as you know, that there's a lot of now research coming up in that the crosstalk between the gray matter and the white matter regions. And it's just not one region specifically that contributes, but a network of different regions that keep talking and contributes to our neurodegeneration. Now, in terms of the community, neurodegeneration could be a very tricky and a very, a lot of jargon. How can we simplify that particular term for people to understand? What is it? Is the death of neurons, or, the atrophy, the brain atrophy? What is neurodegeneration, Gabriel?
So neurodegeneration is the slow breakdown and death of cells that make up the brain. Specifically, it's the neurons. So your neurons are all these like long cells that are connecting parts of the brain. They're all moving around. They're all like connecting and making up our pathways. So neurodegenerative diseases have a slow death of these cells, and that contributes to the atrophy. So the atrophy is that breakdown and loss of mass in the brain. So when you're seeing those components shrink, it's because they've atrophied, so they've lost their mass. And that is because the neurons have died and they've actually just broken down and just been cleared away in the brain. So there's a lot of disorders that have the exact neurodegenerative. So Alzheimer's, Parkinson's, Huntington's, MS.
And not just the neurodegenerative condition, Gabriel, even patients after stroke. Now there is a lot of work that, the brain starts shrinking, especially in the first 3 years. The recent work from Melbourne has shown that the brain starts shrinking for the first 3 years, and that's the best time to intervene and provide the best of treatment for these patients. So really fascinating work, Gabriel, and thank you for informing everyone. And this will, of course, go to YouTube for the broader community to watch. Now, I already opened this conversation for the audience, and if anyone has questions, please feel free to ask. We'll start with our district governor, past district governor, Di North. Di, over to you. If you have any question, Di, please feel free to ask.
I apologize. What I heard was really interesting. So thank you very much. I don't have any questions.
Fantastic, Di. Ronnie, if you have any question.
Your current research that you're going to start, how long are you scheduled to do that for?
My contract at the uni?
No. The experimenting that you're starting this year, is that for just 6 months, 12 months?
So the experiments with the white matter, I think that's going to be 12 months. I think it's really hard to tell because with science, like every time you set out with a plan of this is going to take me 12 months, you always end up kicking yourself because it took you 18 or 24 months. I'm hoping 12 months for this particular study. And I'm hoping 12 months because I'd like to get some other projects up and running as well. So I'm trying to balance a couple of balls in the air. But yeah, hopefully 12.
Yeah, absolutely, Gabriel. And just to complement your answer, unlike any other field of work in medicine, and specifically research is like a black box. You set 6 months deadline, and then you look like we haven't got anywhere because you're really hitting a black box, and you know very little part to answer those questions, and those mistakes makes you a better clinician or a researcher. You try and experiment another part of the brain with a different antibodies, so on and so forth, and the knowledge about that particular part grows. I'm aware that our president Mark Dyer is on the drive right now, so I won't engage with him in terms of question. But Mark, over to you. Yes,
I do have a question if I can.
Yes, Mark. Yes, please go ahead. Please go ahead, Mark.
I read in the Financial Review last week that doing a weekly crossword or a Sudoku is really not the way to keep your brain active. The way to keep your brain active is to talk to people, and specifically young people, and so to stop your brain atrophy or whatever. What's your best advice for keeping my brain, stopping my brain from dying?
So there's a lot of research going into this at the moment for a lot of different disorders. It's really, really interesting. And with Huntington's disease, especially particularly, you know, the age that you develop the disease, for example, is usually dictated by the size of the mutation on your gene. But research is showing that only kind of, you know, accounts for about 70% of the age, and the other 30% is coming from environment. So especially for the brain, being active, we know that physical activity is fantastic for the body. The body loves being active, you know, and especially as you get older, that's becoming more and more important. You know, it's not a time to kind of like slow down. It's a time to just keep going and maintaining that. Diet is showing like this huge impact. So the gut-brain axis, we're starting to really, really appreciate the importance of diet. From what the researchers next door tell me, it's a lot to do with diversity of food and balance, you know, eating a lot of fresh foods, but a lot of different things. You know, our guts love different foods. And the other thing is, yes, social connection is a big one. There's a lot of studies that find that people who stay socially connected, and they have these really lovely networks and support networks, tend to have better brain health as they age. And I think that's because, you know, our brains are happy when we're socializing. We're social creatures. You know, we're not designed to be alone. And I think, you know, during COVID, that's something that was really highlighted. And we really started to think about how much time we spend with other people. So I think as you age, you know, eat healthy, stay active, and keep up with your social network, you know, keep spending time with people. And I think, you know, Rotary is a great example of that. So many people, like, it's such a social community, and everyone's constantly connecting and talking. And so, I mean, you've already joined Rotary, so I just stay current with it.
Fantastic answer, Gabriel. And we call this as a Pcn strategy. So Pcn for physical activity, C for cognitive activity, and N for nutrition. As long as you can keep the balance between Pcn, we all gotta be fine. So, you know, even for patients who've got a neurodegenerative condition, they must keep themselves cognitive active, and Sudoku or any other cognitive task that you can engage in does wonders. So that's so important. Ronnie, you have got a question? Go.
Yeah, just continuing what you were saying, Gabrielle. Some say that after the First World War, with the lack of food, that resulted with some of our elderly having the various dementias and Alzheimer's in there. Do you actually think that because of the COVID-19 strategies, where some people have been actually staying internationally home for 2 years or more, do you think in time to come, for those that didn't interact all that much, we're going to see another brain breakout occurring?
So I'm not sure about this one. So I know that it's impacting on a lot of diseases, particularly in our school. There's a lot of research going into how pregnant women got affected, you know, during this lockdown, you know, because they stopped being physically active and they stopped, you know, connecting with people. They didn't get the same kind of patient care that you would expect. And I think that happened to a lot of people. A lot of people missed appointments because they couldn't get in because of social distancing. My grandmother is one of those. She wasn't able to see a specialist for months. There is something interesting that I have seen a few academics working on, and that is the impact of the infection on your risk of neurodegenerative disorders. There are a lot of theories about the inflammation that the virus caused. In particular, there's some studies that have looked at, you know, outbreaks like the Spanish flu, and then the incidence of things like Parkinson's years later. And I think COVID definitely has the potential to have a huge impact on how those people with those neurodegenerative disorders are impacted. But the only way to tell is to watch what happens, and to see, you know, who is impacted over the next 10 to 20 years, and then try and prepare the next time this happens and go, okay, well, we know the following things are really important. Let's try not to let those slide again. That's a really interesting question. The social connection one, I don't know. I don't think we have enough data yet.
Oh, absolutely. I think we're still getting to learn about these things, Gabriel, and thank you, Ronnie, for asking that question. I am, you know, before we wrap up this session, I would like to thank Gabriel for joining us today. Gabriel, you answered the questions succinctly and with a lot of thought, and we really appreciate your work in Huntington's disease. And I hope that once you're starting a postdoc and so on and so forth, you don't miss on a good supervisor. So obviously, that doesn't happen with you anymore. And this is an important area. I just have a few concluding thoughts for everyone. So we have exciting events lined up at Rotary Club Sydney. And next Tuesday, we have another talk. So please join us on Tuesday on a regular time at 12:30. And please check up our website for our upcoming events. Rotary Youth Talk is there next Saturday at 4 p.m. And you will hear from two of our young speakers again, Lara Ruthstein and Courtney Prahe, who's with the Rotaract. So really fantastic speakers. So join us next weekend at 4 p.m. as well. On that note, Gabriel, I just want to, on behalf of the Rotary Club Sydney, we want to thank you for joining us today and the great work that you're doing in an important part of the brain, which is the Wollongong. On that, Mark, if you have something more to say, Mark, over to you.
Yeah, thank you. I pulled up and I have to leave my car on because otherwise it'll beep. But I think, Gabrielle, you just said that if you continue to attend Rotary meetings as you age, that will help to stop your brain from degenerating. Is that correct? Can I quote you on that?
Yeah, well, you can, because I've been speaking to Rotary a lot, and it talks like this, like they're keeping your brain active, they're keeping everyone thinking about these really complex ideas, they're keeping that cognition going, and then they're keeping you socialized. I've seen nothing but intellectual discussions with Rotary all the time. Like, I think that's something that Rotary really loves. So yeah, I think you can quote me on that one.
Fantastic. I'll stick it in my next newsletter, and yeah, that'll get our attendances up.
Fantastic, Mark. Thank you. And absolutely, I mean, engaging yourself in cognitive tasks improves, and Rotary is a great place to meet excellent people like Mark Dyer or Ronnie Korn and Dynot, who do amazing work, and they engage in cognitively. They're very fantastic. So fantastic, Gabriel. On that note, just want to acknowledge that, in addition to the Huntington disease, we have got Alzheimer's and many other conditions for which we don't have a treatment in neurology. So it's important that the critical work and research continues in this field, so many of the patients who suffer from these debilitating conditions get an answer. For example, in stroke, we have a specific subcategory of stroke patients called CADASIL. Now, these stroke patients are predisposed genetically, and they start having stroke at age of 25 all the way to 35, and they develop multiple strokes, and they have a very poor quality of life after that. Sometimes they die even before 50 and 60. So many other conditions in neurology, we don't have an answer. We don't have a treatment. We don't know what is happening with the brain. So it's important that these patients, and to benefit these patients and the community, we do more research, and that's the importance of work Gabriel does. So all the best, Gabriel, in your research, and we thank you for joining us today. On that note, I want to thank all the people who joined us today. We didn't have much audience, but we'll try to increase that audience as we continue to build this program. And look forward to seeing you next time. And I declare the meeting closed. And thank you, everyone. Thanks, Gabriel.
Thank you.
Thank you, Gabriel. That was really